As we tour Rhineraster Cliffs, we meet the renowned Alabaster we have been hearing so much about. Alabaster asks for our help reviewing their recently upgraded SSH server. The server uses certificates for authentication. Alabaster mentions we could obtain our own certificate using the Azure Function app, generated by ChatNPT. Alabaster also suggests we listen to a presentation by Thomas Bouvet, who provides an introduction to using certificates for SSH authentication. Lastly, Alabaster reminds us that in those cases where the Azure CLI tool is not available, we can always query resources using the Azure REST API. We review our badge to collect our assignment. Our mission for this challenge is to find Alabaster's to-do list. To get started, we visit the Function app website. To request a certificate as monitor, we need to generate our own public key to have the SSH server sign it. We open our terminal and use the SSH keygen command to generate a new set of RSA keys. This command generates both a private and a public key. We give the key a specific name for ease of tracking. Take the generated public key and paste it on the SSH certificate request site. This generates a signed certificate with an assigned principal of ELF. In this case, principal references the role we are being granted. With a valid certificate on hand, we go back to our terminal and save this certificate. We are now ready to connect to the SSH server. We use the SSH command, and using the I flag, we specify our private key and the certificate generated by the server. If we exclude these parameters, the SSH command will attempt to look for keys in its default locations. Once connected, we observe the SAT tracker program running. To close this program, we use the Ctrl+X command and drop into a familiar command prompt. At this point in the challenge, the provided hints become vital. One of the hints reminds us the machine we have connected to is part of the Azure infrastructure running the certificate generation process. As such, we can leverage the managed identity of this VM to obtain a token. This bearer token will allow us to interact with the Azure REST API. The Azure reference documents contains various samples on methodologies to request tokens. We will use the sample given for curl. We copy and paste the provided commands. These generate an Azure token using the VM's identity and store it in the access_token variable. We are now ready to begin querying the Azure API. A different hint indicated we might be able to view how the application is configured by using the getSourceControl API call. Looking at how this request is composed, it becomes clear we first need to collect some additional parameters. The first parameter we need is the subscription ID. The Azure reference docs give us the exact request we need to obtain this information. To make API calls using curl, we follow the previous reference and build our first request. This request will use the bearer token stored in the access token variable. We will follow the curl command with the JQ command. JQ will make the JSON output easier to read on the screen. As our request completes, we obtain the subscription ID we were looking for. Next, we craft a request to find the resource group name. Once again, the Azure reference docs help us find the exact URL we are looking for. As expected, we obtained the resource group name we needed. As we identify this resource name, it is important to note some of this information was displayed on a previous challenge. Specifically, the Azure 101 challenge made reference to these resources. This speaks to how the challenges progressively built on each other. The last parameter to build the getSourceControl API call is the site name. The name of the site is readily available to us in the request certificate site. Having collected all the items we needed, we build the getSourceControl API request and successfully identify the GitHub repository containing the code for this application. We navigate to the GitHub repo and find the Python file containing the app's code. By analyzing the code, we understand how the application is processing the request from the web form. We pay special attention to line 45, where we see we could input a principal value in our request and the application will process it. A little lower in the code, we find the function used to create the certificate. This confirms the application accepts the user's input for the principal value and crafts a certificate using that value. With this information, we effectively find a path to assign ourselves a different principal or role. To exploit this vulnerability, we go back to the request SSH certificate site and generate a dummy request. The sole purpose of this request is to generate an entry we can reuse. Using the Network tab in Firefox DevTools, we analyze the generated request. Since the response contains a principal value, our objective is to observe how the response is crafted. With our sample request ready, we go back to the terminal and generate a new set of RSA keys. We will name these admin. Once generated, we copy the public key. Firefox, as well as other browsers, allows for modifying and sending requests right from the web console, so we go back to it. Right-click our sample request and select Copy as Fetch. Next, move to the web console and paste these requests. Before sending the request, we modify it by replacing the key with the newly generated public key and adding the principal parameter with the admin value. Here, we choose admin as our target is Alabaster, the admin of this application. Our request was successful. Next, we copy the certificate generated from the Response tab. Back in our terminal, use the echo command to write the contents of our certificate to a new file. With the certificate configured, we connect using SSH, but this time we specify the user as Alabaster. Our connection worked. Lastly, we list Alabaster's to-do list and learn he is planning to implement a gingerbread cookie cache system. To conclude this challenge, we go back to our badge and enter the answer. See you on the next challenge.